Math 7A. Today we are learning about volume of spheres. It's our last major lesson. So we're going to try to find the relationship between the volume of a cone, a sphere, and a cylinder if they have the same radius and height. So just compare the volume of a sphere and cylinder to the volume of a cone. In other words, how many cones worth does each of the other two shapes hold? Okay, a sphere, just a reminder, is a 3D shape in the shape of a ball. Now we're going to watch a short video. This is cooperating. Yay! Okay, so they're just setting the sphere up on the little prism to give it a little place to hold it. And he's filling the cone up with some water. The cone has the same radius and height, or the same base shape. If you were to take that sphere apart in half and you could set the cone right on it, so that center circle is the same as the cone. You're just using the pyramid so that it pours better, so don't ignore that. Okay, so there's one cone's worth. And again, the cone and the sphere have the same radius and height. Okay, so it takes 2 cones to fill up a sphere. And remember, we learned last week that it takes 3 cones to fill up a cylinder. Here's your essential question. Okay, let's go back to what we're doing here. There's also a great video that I included as a link. I would watch this too, so that if you use the formula, you can see where it comes from. And then this last one also I'm going to include. This will be a good reminder when you go to do your essential question. Okay. All right, so let's do a little bit of mental math. So notice I set up this chart with cone, sphere, and cylinder. So as long as they have the same radius and height, 1 cone and then 2 cones would equal a sphere, and then 3 of those same cones would equal a cylinder. So a little mental math here, and again, this is kind of contrived, but if you had a cone whose volume was 5 pi, then what would the sphere's volume be? Well, twice as much, right? So that's going to be 10 pi. And what would the cylinder's volume be? Well, 3 times as much as the cone. We're always going to use that cone. So 3 cones would give us 15 pi. Okay, we're going to work backward towards the cone in the second one. So we have a sphere. We know that sphere is equal to 2 cones. So we're going to split it in half, and that's going to bring us back to 4 pi for the cone with the same radius and height as the sphere. And now we're going to go for the cylinder. We know the cylinder is the same as having 3 cones. So 4 pi times 3 is going to give us 12 pi. Here, starting with the cylinder, since we know that this is 3 cones, let's go back to 1 cone divided by 3. That's going to give us 7 pi. And we know that the sphere is equal to 2 cones. So 14 pi times 2 is going to be equal to, 7 pi times 2 is going to be equal to 14 pi. And the last one, we have the sphere. We know that's equal to 2 cones. So if we divide it by 2, we can get back to a single cone. That's going to be 10 pi. We know the cylinder is going to be equal to 3 cones worth of volume. So 10 pi times 3 is going to give us 30 pi. So this is what the idea is going to be on your homework. You're going to need to actually work out a more complicated problem, but then you're going to use the relationship between the 3 of these shapes to answer the other questions and keep those short. Okay, so here are your formulas then. We have over here our cylinder is BH. We know a cone is BH divided by 3. So a sphere is just going to be 2 of those. Instead of 1/3, think of this as 1/3 BH, this is going to be 2/3 BH. So it's 2/3 the size of a cylinder. The official formulas are down below where they're substituting in that base shape. This one's a little more complicated. You'll have to watch that video to see it. But you get that base shape times the height, base shape times the height, and then divided by 3. All right, let's use our calculator on this. So we're going to find the volume of this sphere. So the volume is going to be equal to 2 base times height all over 3, so 2/3 of that. And our base, okay, so it's kind of a stretch, but you're going to consider that center circle at that, right at the middle as the base. It's kind of like you could cut it in half there and put them one on top of the other. So we're going to, again, if you watch that other video, that green video, then you'll see what I'm talking about. I think it's a good way to remember it, because I have never remembered this formula from year to year. But now that I've started teaching it this way, I never forget these. So it's just so much easier than working with these other 3 formulas. Okay, so 3.14 times the radius, which is 7, and we're going to square that. So it's going to be 3.14 times 49. Make sure you have your calculator handy. So when you estimate it, it should be about 50 times 3. So it should be about 150, but let's actually calculate that. It's good to estimate when you do this so that you know whether your number's coming out to be something reasonable. It's very easy to miskey something when you're using your calculator. Okay, so I'm getting that for my big B. So volume equals 2 times big B, which is 153.86, times the height. So your height is going to always be twice your radius. So your height, again, this is a little bit of a stretch. Purists won't like this, but your height is twice the radius, because your radius would be, that's 7, so the height is 14. All over 3. Okay, so just go ahead and plug and chug. So we've got 2 times 153.86 times 14 equals, divided by 3. So that whole thing comes out to 1436, and we'll just round to the nearest tenth, which would be 0. So let's just leave it at that. Okay, and that is our volume. So let's say units cubed. Okay, what would the volume of a cone be with that same radius and height? Well, you know that there are 2 cones in this volume, so let's take half of it. That's how much one cone would be. So the volume is going to be 1436 divided by 2. That comes out to, what, 718, right? And that's cubic units. Units cubed. Well, what about a cylinder? Well, a cylinder is the same as 3 cones. Now, if I know that 1 cone is this, just take it and multiply it times 3. I gotta use my calculator for that. So 18 times 3 equals. So there you go. Units cubed. Let's try another one. So it's all about getting back to the cone after this. So volume 2/3 big B times height. Big B is a circle still. Pi r squared. So we've got 3.14 times the radius. This says diameter is 12, so that means the radius is going to be 6. Square that. So we have 3.14 times 36. So that comes out to 113.04. Now let's plug that into the volume formula. So 2 times 113.04 times the height is going to be the same as the diameter. So the height is going to be equal to 12. All over 3. I see an opportunity to cancel here. This is going to be a 1. This is going to be a 4. It saves me a little bit of time. So 2 times 113.04 times 4 equals 904.32, and that would be cubic units. If we want to go find a volume with the same, a cone's volume with the same radius and height, we know since it's 2 cones for the sphere, to find 1 cone, just divide it in half. So 904.32 divided by 2 is going to be 452.16, and that's units cubed. If we're going to find the cylinder with the same radius and height, and now we know one cone, we can just triple it, times 3. So 452.16. So times 3. That's giving us 1,356.48, and that's units cubed. All right, last one. So here you have decimal. So your sphere is this. Oops, sorry. This is big B. Sorry, let's just erase that. Okay, big B equals pi r squared. So 3.14 times the radius is 0.5, and that's squared. So 3.14 times 0.25, and let's multiply this out. 3.14 times 0.25 gives us 0.785. So that's our big B. So our volume equals 2 times 0.785 times the height. If the radius is 0.5, and the height is going to be twice that, so the height is going to be equal to just 1. All over 3. So now we have 2 times 0.785. Don't really need to multiply times 1, see what that equals, and then divided by 3. I have 0.52 with 3 repeating, so let's just call it just 0.52 units cubed. If you're looking for a cone with that same radius and height, take half of it. All right, so that's going to give us what? 0.26, right? So that's units cubed. And then if you're looking for the cylinder, that's going to be 3 times the cone's amount. So 3 times 0.26. So 3 times 0.26 equals 0.78. And that is that. So use that when you're doing your homework. And then remember, keep your answer to your essential question really, 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 really simple. Okay, just relate it, how many cones in each of those other figures.